So this one's hypothesizing for difference between two proportions and hypothesizing for difference between two means. Now I put these two sections together because they're pretty much the same concept. Again, just like every hypothesis, the only thing that changes is finding the test statistic itself. Okay, but since we're doing proportions and two means, when it comes for your null and alternative hypothesis, you can compare the actual two proportions themselves. So your null hypothesis is going to be the P1 equals P2, the two proportions, and your alternative is going to be one of those three, not equal, less, or equal to that same value. Okay, and same things for the mean. It's going to be mu1 equals mu2, and same thing applies, not equal, less than, or greater that different mean itself. Okay, so that's good. We're comparing, so these are actually going to be values themselves. It's going to be straight out. These are the letters, and figure out which ones go scenario-wise itself. Okay. Now, for test statistic for two proportions, this is going to be our test stat. Now, notice that looks like a horrible equation, and it actually is. So when it comes to it, and it's even worse because P with a hat over it is considered this. So it's even more complicated when it comes into play. Okay. Now, the good thing is I will actually give you that as well, so you don't actually have to physically calculate that when it comes to this stuff. Again, because we're online, I'm going to give you guys a little help for that. Okay. Now, same thing applies for the test statistics for the mean. For the t-value, again, notice looks not as bad as the z-score one, but still looks pretty horrible. But again, I will give you this as well, okay, when it comes to it. However, the only thing you will have to know is how to find degrees of freedom. So the degrees of freedom is the smaller of the two sample sizes of n-1 or n2-1. So again, they're going to give you two samples because we're dealing with means, and the degrees of freedom is the one less of the two smallest ones. Okay, so that's when you do have to verify, because again, we have to find our critical value associated with it to see if we're going to be rejecting or do not rejecting. Okay, and the last thing is conclusion is the same as the above when it comes to using the boxes or write your own as well. Okay, so the best thing I always want to do is give you guys an example so you can see how this is actually template and seeing how me giving you this is going to look to the problem itself. Okay, so let's try a couple examples. Okay. So question 1 says, in a random sample of 30 people playing slot machine, the mean average was 50.7 years with a standard deviation of 5.8 years. In a second sample of 39 people playing roulette, the mean age was 59.3 years with a standard deviation of 2.2 years. Now, we're not going to find the confidence interval because, when it comes to it, but we want to do this. So we're just going to eliminate this right here because we did that last portion. But we want to do this one. Can it be concluded at alpha equal 0.05 that the mean age of those playing slot machines is less than those playing roulette machine? Now, if you're wondering how in the world do I know what p hat, p1, p2 is, mu1 and mu2 is when it comes to it? Well, let's first, I'm sure we all agree we're going to be doing for mean, right? Because we want to do the mean right there. So we know it's going to be this situation here. Okay. Now, when you find your mu1 and mu2, you always want to look at the actual question itself. Okay. So what are we comparing? So here's our less than sign, right? That's a symbol we're going to be dealing with. So we're representing the mean ages of slot machine and mean age of roulette people. And that's how we're going to identify it. So when a slot machine is going to be mu1 and roulette players are going to be mu2. Okay. And that's how we always want to do it when it comes to these type of questions, is you got to look at the actual claim itself, and that's going to show you what mu1 and mu2 is, p1 and p2 is going to represent. Okay. So in this case, our null hypothesis is going to be mu1 equals mu2, right? We're assuming the means are the same. And then your alternative hypothesis is, since we want less than, so we know mu1 corresponds to our slot machines, is going to be less than mu2, which corresponds to our roulette players. Okay. So that's step 1, right? We wrote that down, right? Our muse itself. Okay. Now for step 2, notice it says given t equals negative 7.706. So step 2 is done. Figure out what I mean by that. So our test stat is negative 7.706. So that's why it's going to be given to you in the question, right? And now from there, we have to finish it up. So we have to find our critical value and all that fun stuff and see, if we reject or do not reject when it comes to it. Okay, so we have a left tail test for sure, right? So we need an alpha, which is given to us because it's 0.05. And we also have degrees of freedom. Now remember, degrees of freedom is we have to see which one has the smallest of the samples, right? So this had a sample of 30, and this had a sample of 39. So the smallest of this is going to be 30, right? 30 is smaller than 39, and that's where corresponds to this degrees of freedom. So now the degrees of freedom is going to be 30 minus 1, which is 29. Okay. And at this point, we go to our table to figure out what our critical values are going to be. So given an alpha 0.05 and degrees of freedom of 29, it's going to be negative 1.699. All right, so since our test set is definitely within our region, we're going to reject our null hypothesis. Okay. And then finally, we're just going to write our conclusion, just like we've done so far when it comes to these. Okay. So again, just following the boxes. I can just say it out loud for you guys. So we can say the sample data supports the claim that, and you can say exactly this, that here, there to there, that the mean age of those playing slot machines is less than those that play roulette. And there you go. So that's what these type of questions are going to look like. Again, since this is given to you, that technical mathematics is kind of helped you out when it comes to it. It's a pain just to figure that that t-value out itself. Okay. All right, now let's go to number 2. Okay. So number 2 says, in a survey, 80% of men that were questioned if they preferred computer-assigned instruction to lecture-based, and 73 of women preferred computer-assigned instruction to a lecture. So basically what we're doing now, right? Do they prefer computer or actual instruction in class stuff? There was 100 men and 100 women surveyed in the study. At a 0.05 alpha, test the claim that there is no difference in the proportion of men and the proportion of women who favor computer instruction. So here's our claim, right? And just like I said earlier, right, you always want to quote. So we have no difference, right? So let's say our P1 is going to be the men, and P2 is going to be women. So when it comes to our null hypothesis, it's going to be P1 equals P2. And for our alternative hypothesis, since we want no difference, that means it's going to be not equal to it. Okay. Now we go on to step 2. So again, notice given z equals 1.17. So again, we're given our test stat. Okay. All right, so now we're going to find our critical value. And since we're doing proportion, you do the exact same thing. You just go to a little table we used earlier for proportion, and do the exact same process here. So that good thing has not changed. And so since our alpha is 0.05 and we have a not equal to, right, so we have a two-tail test. So our critical values are going to be here and there, a 1.96 and negative 1.96. Okay. Well, our test stat is roughly here. So it's not in the region, so we do not reject H naught. And then finally, step 3, we write our conclusion down, right? So again, if you guys go to the boxes, so there's no difference. So if I have no difference, that's you got to be careful, right? So there's actual equality, because there's no difference means you're equal, right? So if I say I am no different than you, that means we're equal to each other. So you would say yes, there's equality. And again, this one we do not reject, so it'll be a no. So you would be in the second box. So this one would say there is not sufficient evidence to support there is not sufficient evidence to warrant rejection of the claim that there is no difference in the proportion of men. There's no difference in the proportion of men and proportion of women who favor computer sewing instruction to lecture-based. So it's a lot. I know it's a lot of writing, but that's what all hypothesis is. Mostly, it's a lot of writing and a lot less math when it comes to, because you're analyzing information, right? For a company, in this case, or a survey. In this case, I get even more surveys when it comes to it, things like that. Okay, so when it comes to your conclusions, don't just do one little thing. We do this, do that, just like we did in the last sections. Make sure you have to write the whole process out as well. Okay? And that's pretty much it. That's for hypothesis testing for difference proportions and difference from two means. Again, it's not too difficult, as long as you can bypass these two. It's the exact same process when it comes to that.